Okay, so today we're solving rational, and it's not expressions anymore, it's equations because there's equal signs. We have equal signs now. All of these guys, every single problem we see today, there's an equal sign. That's why it's an equation. So we're solving. So the first one we look at is two fractions equal to each other. Okay? So when we have two fractions, called a proportion. Proportion means two fractions equal to each other. Okay? Okay, so there's a couple different ways to do it. There's kind of an easier way, and then there's kind of a different way to do it. I'm going to do both. So if two fractions are equal to each other, they have to be exactly the same, right? Like 1/2 and 2/4 have to be exactly the same. So one way to do it is the 2. What can I do to the 2 to turn it into a 4? Is there something I can do to the 2? Multiply by 2, right? I can multiply this guy by 2 to get over there, right? So if that's true, then the top has to be true as well, right? Because they're equal. So that means this guy would be 18, right? If that works, you can do it. But sometimes you can't do that. Sometimes, like, this is not a nice number like that. Sometimes it's like 11, right? Doesn't really work out as nicely. So I'm going to give you another way to do it. Another way to do it. Another way to do it is called what we call cross multiplication. Cross multiplication or butterfly method. Okay? Cross multiplication means multiplying diagonal over the equal sign. So over the equal sign. So it kind of looks like butterfly wings. Equal still in the middle. We still have equal sign. Okay? So the green, 2 times x. 2x. The pink, 9 times 4. 36. How do we get x by itself? What do we got to do to get x by itself? Divide by 2. We knew the answer already. It was 18. Well, the answer is still 18. Okay, the answer is still 18. That's another way to do it. If you have a fraction, equal a fraction. It's always the case, right? Even if I have two fractions, 1/2 and 2/4. I know those are true. How do I know those are true? Because they're both half, right? Well, if I do butterfly method, you don't have to write this down, but if you do butterfly method here, you'll get 4 equals 4. That's how you know a fraction equals another fraction, if that's true. Okay? If that relationship works, then you know it has to be true. You can also do it if you have two numbers. Let's say I have 4x equals 16. Well, you can turn these into fractions. We usually don't do it this way, but you could do that. Okay? And it would give you 4x equals 16. It would give you the same thing again, right? But you can do that too. You can do it with fractions, you can do it with non-fractions, as long as they're equal to each other. Okay, letter B. -7/4 equals 8. So I know I can use the butterfly method. Here's my question. So let me use the butterfly method. So when I multiply, one of them's got a negative, right? One of these guys has got a negative. Who does that guy go with? The 7 or the 4? The answer is it doesn't matter. Could go with the 7. Could go with the 4. The only thing is you can't go with both, and don't forget about it. Okay? So if you want to move the 7, if it feels better to go up with the 7, do it. Or you can go down with the 4. You just can't do both. Don't do this, -7 and -4. That's not right because -7 over -4 is not negative anymore. It turns into be positive. Okay? And don't forget about it. Just pick one. Okay? So if I put it at the top, it's going to be -56 and 4x. And if you divide by 4, you get negative 12, 13? No. 13, yeah. No? What do you get? Negative 56 divided by 4, 14. Done. Okay? You've done those before. You guys have done those probably in elementary school and junior high. Today, we're going to work on some that will look more like what the bottom is, down to the bottom. Still the same steps, though. The same steps. These are all monomials, right? These are all one term. The ones we're going to see today are binomials and trinomials, but it's nothing you guys haven't done before, right? First problem, we have a fraction equal a fraction. So the first thing I do is if it's a binomial, put them together. Okay. Next thing, it's one fraction equal another fraction, cross multiply. Equal stays in the middle. So on one side, I get 5 times the binomial 2x minus 8. And on the other side, I get 8 times the binomial x minus 2. Okay. Now I have to solve. So to solve, I have to do distributive property. Eight x minus 16 equals 10x minus 40. So to solve, I got to get x's on one side, numbers on the other. Right. So you could either subtract 8x from both sides or subtract 10x from both sides. It doesn't matter. You'll get the same answer. Okay. Now I got to add 40 to both sides. I get 24. Divided by 2. I get x equals positive 12. I'll pause right there for a second. The reason I paused is because we did cross multiplication, we solved. Now we got to do one more step. One more step you've probably never done. Check for extraneous solutions. Check for extraneous solutions, it says it in the problem. We've talked about extraneous solutions before. We've had tests on it, quizzes on it, homeworks or classworks on it, Delta math assignments. What does the word extraneous or extraneous phrase, extraneous solution mean? Does anyone remember? Extraneous? When did we see that? What does it mean? Something that didn't work, right? An answer that it makes it not equal. Something that doesn't work, right? So when doesn't it work? Well, let's think of a fraction. Think of a fraction, right? Something over something. When what value, what number can I not have in a fraction and where can it not be? Your calculator will even tell you this. Your calculator will say, nope, can't do it. So not numbers, right? Because if it's like 2 over 3, I can do that. I can go to my calculator and I can say, what is 2 divided by 3? Oops. And it'll give me an answer, right? But there's one thing that if I put into a fraction, it'll say error or it'll say undefined, means there is no number. There you go. If I put 0 in the bottom, my calculator will tell me, no, can't do that. If I put 0 on top, it's okay. Watch, I'll do both. 0 divided by 2. Calculator just says it's 0. But if I flip them, 2 divided by 0, my calculator says undefined means there is no number. Doesn't exist. Some calculators, if you put them in, will say error, right? Because you can't have 0 on the bottom of a fraction. Can't have it. So that's what we have to check our answer for. If I was to take my answer and plug it in here for x, would it give me 0 as an answer? There's only one way to find out. 2 times 12 minus 8. Well, 2 times 12 is 24. Minus 8 is 16. That's not 0. I'm good. Right? And I can't plug it in anywhere for 8 because 8 is, there's no x. So I can't plug it in anywhere. So if this was like x minus 12, if it was like x minus 12 and I plugged it in 12, that would make 0. Then 12 cannot be it's called extraneous, right? But when I plugged in 12 to the bottom, I don't have to worry about the top because the top, my calculator said 0 on top, you're okay. 0 on bottom, no go. Okay, so I can't have 0 on the bottom. So I just have to check to see if the bottom of any fraction is going to be 0 with my answer. Okay? Okay, so let's do B now. Actually, you guys can do B. Do B on your own. I'll give you a chance to do B. Try B. Okay, so I distribute the green. So it's 2 times x minus 7 and 5 times x minus 1. Distribute. 5x minus 5 equals 2x minus 14. Subtract 2x from both sides. Add 5 to both sides. I get negative 3. Okay. Now I have to go back to the original question and see if I were to plug in negative 3 to the bottom, the denominator, if I was to plug it in here and here, would I get a 0? Would it cancel out? No, because negative 3 minus 7 is not 0, it's negative 10. And negative 3 here, negative 3 minus 1 is not 0, it's negative 4. So because of that, negative 3 is an answer. It's okay. It works. Okay. All right, so let's flip it over. And let's look at example number 3. So before I start this, I always put parentheses around my binomials just to make sure, just to remind me they're binomials. And I treat them differently than monomials. Okay. Okay. Fraction equal a fraction. So okay. I get negative 4 times x minus 5 on one side, and I get x times x minus 3 on the other. So next I got to distribute. Okay, all right. So I get x squared minus 3x equals negative 4x plus 20, right? Because negative 4 times negative 5 is plus 20. So how is this problem different right now? Because I need to solve it. How is this one different than the ones we saw just on the last page? There's an x squared, right? So how do we solve things with x squareds? We've done this many, many, many times before. We use the steps, right? We use the steps. The only difference between the steps on the steps we've been using, we make it a trinomial, right? It's got an equal sign. So let's set it equal to 0. That's the first thing. Set it equal to 0. Okay? So doesn't matter if you get everything on the left side or the right side of the blue line. Get everything on the same side. So I'm going to add 4x to both sides. Subtract 20 from both sides. That gives me a trinomial. Once you get there, you guys, this is right in your wheelhouse. You guys have been doing this since last semester. Set it equal to 0, done. Does the trinomial have a GCF? Besides 1, no. ABC. A equals 1, B equals 1, C equals negative 20. Negative 20, positive 1. So let's see. The two numbers that multiply to be negative 20 add up to be 1. Negative 4, positive 5. Okay. So we get x minus 4 and x plus 5. That's factored, right? That's factored. So I have, let me move over here, x minus 4 and x plus 5 equals 0. This one, now I have to solve it. So what do I have to do when I'm solving? Set it equal to 0, yeah. Set them equal to 0. X minus 4 equals 0. X plus 5 equals 0. And I get two answers. Okay. So I get 4 and negative 5. So I'll stop right there for a second. Last step, I have to check to see if it's extraneous. Okay, so at the bottom, the two denominators. If I were to plug in a 4, so let's see, if I were to plug in a 4, 4 minus 5 is negative 1. That's okay, negative 1 is close to 0, but it's not 0. Here, I just plug in a 4, I just get 4. We're okay. Negative 5. If I were to plug in negative 5 up here, what's negative 5 minus 5? Negative 10, yeah, not 0, so that's okay. And negative 5 would just be itself. So both of these answers are okay. So in Delta Math, 2 boxes, hit enter twice, you are done. All right. Okay, so we'll do letter B now. Do letter B, right below it. All right, so here's what I got. I got 6 and positive 12. And then if I plug in 6 here and here, I'm going to get negative 2 and 6. That's not 0. So this guy is okay. And if I plug in 12 here and here, 12 minus 8 is 4. And then just 12 by itself is not 0. 2 answers, 2 boxes. Enter twice. Okay. Okay, so the next step we're going to focus on is, what if I don't have 2 fractions? What if I have more than 2 fractions? One equal sign, more than 2 fractions. Okay. Well, it's not that bad, actually. You've done it before. You've done these steps before. You just never put them together. So let me break this up here. Okay. So what if I have something like this? I have an equal sign, but on one side of the equal sign, there's 2 fractions being added or subtracted together. What do I do? Well, this is what we're going to do. We're going to do a mixture of what we've been doing. So what we're going to do first is we're just going to focus on the 2. I'm not worried about what's on the other side of the equals. I could care less right now. I'll deal with it later, right? Deal with what's in front of you. Okay? You've seen this type of problem on your quiz. You saw this, right? How do we add these 2 fractions together? What do we need? What's the first step we need? Common denominator, right? So we break down the denominators, right? I break down 5 and x. They're monomials. If I was to do a tree for 5, it wouldn't be a very big tree because it's just 5 times 1. Same thing with x, just x. What's missing? Well, yep, this guy needs an x, and this guy needs a 5. Well, again, this is a binomial here. So the 5 is going to go in the front. Okay. So just like we did on the quiz, we have a common denominator now. The common denominator is 5x. On top, we have a 4x plus 5 times x plus 4. Right? We do what we did on the quiz. Distribute. So when I distribute, I get 4x plus 5x plus 20. Combine like terms. I got some like terms here. I can combine 4x and 5x. I get 9x plus 20 over 5x. And that's where you stopped, right? That's where you said, I'm done. Done with that problem, moved on. I think this was like the last problem you had, number 5 on the quiz. And you're like, I'm done there. Right? Today, we're not done. We have something on the other side. Now we bring in the guy that I have not used yet. And we bring him down to where I'm at now. Now, this looks like a problem we've been working on. We're going to do it the same way, right? This is a binomial. We're going to cross multiply. Okay. And we continue like we did on the last problem, the last 2 problems. The green side is 5x times negative 7, negative 35x. The other one is 5x times 9x plus 20. Okay. Distribute. We get 45x to the second power plus 100x okay. Well, it's got a squared, just like the ones, the big numbers, but it's still got a squared. So we're going to get everything on one side, set it equal to 0. So I'm going to add 35x to both sides. Yeah. How did I get 35x? Oh, right here, negative 35. I did on, here I had 5 negative times negative 7. Negative 35, is that right? Negative 35x?
Yeah, but I didn't. Doesn't 5 have an x, so you can't multiply it by 7?
No, you can. If they're monomials, you can. Yeah, you can. It's yeah, I couldn't add them or subtract them, but multiplying we always can, yeah. Yeah. So what do we get here? 45x squared plus 135x equals 0. It's a binomial. It's only got 2 terms. So it's already equal to 0. We got to factor out a GCF now. Definitely x. We got to figure out the biggest number that goes into 45 and 135. Well, 5 definitely, because 5, they both end in 5, right? But let's see if there's something bigger. Let's see. 9 goes into both? Was it 135 divided by 9? 9, and then what did you say? 45? 45, what am I doing here? 135 divided by 45. Yeah, 45 goes in both. So I think there's a lot of numbers that go into both, but the biggest one is going to be 45. And we always want the biggest. The GCF means the biggest. So 45 and 45. So 45x, that makes 1x plus 3, because it goes in 3 times. Okay, so I have 45x, x plus 3 equals 0. So you have this guy times the monomial times the binomial equals 0. So if both of them multiplied together make 0, that means one of them, if not both of them, have to be 0. So I set them equal to 0, just like I did earlier. And I'm going to get 2 answers. Zero on top makes 0. That's okay. My calculator's okay with 0 being on top. So that one's okay. The other one, negative 3. Okay, so let me go back to the original. Are any of those 0 or negative 3? Are either of them extraneous? Yeah, 0, because if I put in 0 here, that's just 0, right? And if I put in 0 here, it's 5 times 0. 0. So let's cross out 0 and write extraneous solution. So definitely don't want to enter that one into Delta Math, unless it asks for extraneous. Sometimes it'll say, only give me extraneous solutions. Then yeah. But if it's asking for just solutions, then definitely not. Let's check -3. -3 is okay because it's just -3. And then 5 times -3 is -15. That's okay. That's not 0. So that answer, I can put it. -3, I can put it. One answer, one box. You're not going to use 2 boxes. You're only going to use 1 box. Okay? All right, so I want you to try the last one. Last one we're going to do. We're not going to do any more extra problems. Last one we're going to do, letter D. I'll give you some time to work on that, and then we'll go over it, and then we'll be done. Okay, so I did the first step, which was common denominator, get those 2 guys together. So the common denominator is 4x. First guy needs an x. The second one needs 2 times 2, which is 4. So -3x minus 8 times 2 times 2, which is -32. I stopped right there for a reason. This is a trick you can use. Not a trick. It's just noticing it. Sometimes you don't notice it. So look at these 2 fractions. What do you notice about these 2 fractions that stands out? Anything stand out to them? They have a common denominator, right? The bottom is exactly the same. So let me ask you this question here. If I knew this guy was 1/2, and I didn't know the top, but the bottom was a 2, what does the top have to be? 1, right? It has to be 1. There's no other number it could be up there for the question mark besides 1. If the bottoms are the same, what also has to be true of the top? They have to be the same. If you ever see that like this, and you have a common denominator there, you don't have to do butterfly. Now, it's not wrong. You can do it. Butterfly works, but it might save you some work. If the bottoms are the same, all you have to do is set that equal to each other. So in other words, you can just solve this guy. -3x minus 32 equals -5, and solve that way. And you'll get the same answer. I'll show you. Add 32 to both sides. (27) divide by -3. -9. Now you got 2 answers. One of them was 0, one of them was -9. The reason I only got 1 answer is what's up with 0? It's extraneous, so I wouldn't even count that as an answer, right? So the way, if you did butterfly, which you all did, it's okay. There's nothing wrong with it. I'll do it right now. I'll do butterfly right now. But I just wanted to show you that that's another way of doing it. Okay? If you see that. If you don't worry about it. I'll do butterfly right now. Butterfly will work as well, but it saves you a little work. So you do distributive property, and you get -12x squared minus 128x equals -20x. I'm going to add 20x to both sides. -12x squared, and this would be a -108x. GCF is -12x. X plus 9. -12x equals 0. X plus 9 equals 0. Divide by negative 12. Subtract 9 from both sides. You get x equals 0 and x equals negative 9. So, and we talked about 0 doesn't work. 0 doesn't work because 0, 0, and that'll make a 0. So 0 is extraneous. Extraneous. So the only answer you would get is negative 9. So when we're doing practice tomorrow, and you see that, hey, these guys already got the common, it's fraction equal a fraction, then you don't have to worry about doing that. Just look at the top. Just look at the top and say, this guy has to equal this guy. And solve it that way. It'll save you a little bit of time. If you don't see it, are you wrong? No. It just takes you a little longer. That's it. Okay? All right. Okay, so tape those in, and we'll do some practice tomorrow.